Rectangular coordinates. In industry, the movement of machine tables is done by using the concepts of the rectangular coordinate system. Milling machines, turning and machining centers, jig borers, and practically all of the CNC or computer numerically controlled machines use principles of rectangular coordinates. To use or program these machines, you must have a knowledge of the rectangular coordinate system. This system consists of two perpendicular lines called the axes, which intersect at a point called the origin. This origin is the point 0, 0 because it's at the point 0 on the x-axis and 0 on the y-axis. The x-axis is the horizontal line, the y-axis is the vertical line. If we have to read a point on this system, we need to find the x-coordinate first and then the y-coordinate second. So let's look at point A here and find how far over from the origin we have gone. We have gone 1, 2, 3, 4, 5 spaces over, and this is shown here. We've gone 5 spaces over. So for point A, our x-coordinate is 5. To find our y-coordinate, we need to know how far up from the origin we have gone. If we start at that origin, 1, 2, 3, 4, we have gone 4 up, shown by this distance here. Our y-coordinate then for point A would be 4. These lines are not always drawn for you. You need to find out a coordinate without the lines. Let's find out. We're going to start at the origin and find the coordinates for point B. If I'm starting at the origin and I need the x-coordinate first, I need to move right or left. To get to point B, I would need to go left 1, 2. I'm at -2. So my x-coordinate is -2. Now I need to know how far up I would go for point B. If I'm at -2, 1, 2, 3 up on the y-axis tells me that my y-coordinate is 3. So remember, you're starting at the origin, you're moving right or left first. Then you move up and down. Right or left gives you your x-coordinates. Up and down gives you your y-coordinates.
It's important for you to understand rectangular coordinates. I'm standing in front of a very basic milling machine. And this machine moves in the x direction and in the y direction. And so we have this y and this x. But if you want to get to this point over here, you have to move over to the x and then up in the y. And there's hundreds of thousands of machines like this. And they all move in the x plane and in the y plane. Now watch what happens when I go to this digital readout. And I'm going to zero them out. This is the, notice on the top one and the bottom one. Now I'm going to move it in the x direction. Notice it's minus. And this says x here. And when I move it in the other way, opposite direction, it's in the positive. There's no symbol for the positive. And the same for the y. Watch what happens. I'm going to go over to the other handle over here. And I move this way, it goes in the positive. And this goes in the negative. And I pass the 0. I'd like to show you some practical applications for rectangular coordinates. Watch this video and notice the operator of this computer numerically controlled mill, or CNC mill at NASA, explain what the machine is machining and how one must have an understanding of the x and y axis.
Typically, we make patterns such as what you see right here. This foam pattern is used to lay up a mold, and then the flight panels for the X-38 reentry vehicle will be made out of those molds. So you have to have an understanding of math to be able to determine where this machine is going to go. like if you have a machine register, you set where your XYZ0 is at one portion. And when I bring in a program, I have to look into the program and determine before I actually start running it where the machine is going to drive to. That's by looking at the XYZ values.
All right.
And verify that yes, this is where we want the machine to go, and it's safe to go ahead and let it run.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.